Okay, so let's, good morning. My name is Paul Jacobi, and believe it or not, I still vividly remember a particular morning in June. It was a Monday. I had just graduated Indiana University a few weeks earlier, and I found myself at the front door of 110 Fibre Road, reporting for my first day at work in VMS engineering. Well, 38 years later, I'm still in VMS engineering, so I'm happy to be here today. So for today, I would like to share my experience with Fibre channel and OpenVMS virtual machines. The topics for my presentation here includes the two different modes of using Fibre channel in a virtual machine environment, how OpenVMS 9.2-3 works in both modes. Both modes have their own strengths and weaknesses. And I have some examples of configuring VMware ESXi in both modes. And after all that, we'll look at some challenges for the future. So the central problem here, the question is you need to pick one and only one owner for the Fibre channel host bus adapter. In mode 1, the hypervisor controls the Fibre channel host bus adapter. I call this mode 1 because it's a default when you set up either VMware or KVM. The second way to control the Fibre channel host bus adapter is for OpenVMS to control the Fibre channel host bus adapter with PCI pass-through. Now you can have multiple Fibre channels cards installed in your system and use those cards in different modes. However, you cannot take a single multi-port Fibre channel card and split it between different modes or different virtual machines.
I tried that.
It doesn't work good. So you have a limit there of the number of PCIe slots on your system. The mode selection of how you select the mode the card is in is very easy with ESXi. I have some screenshots that I'll go through a little later to show you that. With Linux KVM, it's a little bit more complicated. So in mode 1, the hypervisor controls the Fibre channel host bus adapter. Again, that's the default mode when you set it up. So in this mode, the hypervisor provides a device driver for the Fibre channel host bus adapter. The Fibre channel ones are then formatted with the hypervisor file system and can be shared by all virtual machines. Virtual disk files can be created on those Fibre channel ones, and the storage provided to OpenVMS virtual machines. OpenVMS accesses the storage through a virtual interface, such as SATA, SCSI, or VirtIO. OpenVMS actually has no idea that this storage is actually residing out there on the Fibre channel in this mode. And the advantage of using this system is you can use this mode for storage adapters such as iSCSI and RAID that VMS doesn't have a driver for, but the hypervisor does. That also works. And this method works all the way back to VMS 9.0 with any Fibre channel adapter supported by your hypervisor. So in mode 1, a user program requests a QIO from a DK device. DK driver formats a SCSI command packet. It hands it off to a port driver, which can be PKD, PKM, or VSP driver, which submits the SCSI command packet and a buffer descriptor to the virtual port. The hypervisor then accesses storage in a virtual disk file on the Fibre channel 1. The hypervisor performs a DMA operation to hypervisor memory space. The hypervisor then copies the data from hypervisor memory space into OpenVMS memory space. And this operation is known as a buffer DMA, or sometimes called a bounce buffer, because the data only temporarily resides in the buffer before being moved somewhere else. This buffer DMA operations is going to increase the CPU load on your hypervisor. And at the end of all this, the hypervisor generates an IO completion interrupt to PGQ driver. PGQ driver completes the request back to DK driver. DK driver completes the request all the way back to the user program, and you're done. Let's look at an example of how mode 2 works, where OpenVMS controls the fiber channel host bus adapters through PCI pass-through. In this mode, the hypervisor does not touch the fiber channel host bus adapter at all. It's a hands-off for the hypervisor. The hypervisor does program something called the IO memory management unit at VM power on, and I'll explain more about that in a minute. The hypervisor then provides VMS with an open window to the fiber channel host bus adapter hardware. OpenVMS then must have a device driver for the particular fiber channel host bus adapter. The VMS driver then performs direct map DMA to that adapter, but does not modify the IO MMU. The fiber channel host bus adapter then must be dedicated to that particular OpenVMS VM. The granularity is a PCIe slot, not the ports. And then, of course, you're limited by the number of PCIe slots in your system. A couple of restrictions here, that this mode requires the use of locked memory. I'll talk a little bit more about that in a minute. And you cannot use something called vMotion to move this virtual machine around to another host. So in mode 2, a user program requests a QIO from a DGA device. DK driver is there again to format a SCSI command packet. It submits it on to PGQ driver, which is the port driver for the QLogic fiber channel host bus adapter. It takes that SCSI command packet, combines it with a buffer descriptor, and submits that to the fiber channel host bus adapter. The fiber channel host bus adapter performs direct map DMA operation, and the IO MMU comes in to transparently steer the DMA directly to the OpenVMS guest memory space without any data copies. PGQ driver gets an interrupt and completes the QIO request back to DK driver, and DK driver back to the user program. PGQ driver here works exactly like it's working on bare metal. In fact, it is running on bare metal. So what is this thing called the MMU and the IO MMU? Well, both are basically a type of page tables. We know the MMU is the thing that translates the CPU's virtual addresses into physical addresses. When you have a hypervisor involved, you have something called a virtual MMU, which translates guest physical addresses into host physical addresses, one more layer. And in contrast, the IO MMU translate an IO bus address to a physical memory address. The IO MMU is also known as IO map registers. And in the old days, we used the IO MMU to map a much limited IO bus address space into a much larger system memory address space. So some examples include mapping the 18-bit unibus IO addresses into 32-bit VAX memory. Similar for the QBus, and a more recent example is mapping a 32-bit PCI IO space into a 64-bit memory address space on Alpha and Itanium. Now, at some point in the PCI specifications life cycle, PCI was updated to include full 64-bit IO addressing via something called the dual address cycle. And when I presented this new platform to a device driver writer, I thought they'd be excited about this feature because you wouldn't need map registers anymore, make the driver much simpler. But in fact, it made the driver much more complicated because this feature was going to be platform dependent, and the driver still had to maintain set of code for both map registers, with map registers and without map registers. It made the driver more complicated, and as a consequence, most drivers, they just left using map registers, and that's it at this point.
It also makes it worse because if you're doing 64-bit direct, you still have scattered data.
Yeah,
And
yes, and that you still have to account
create
for
a
that.
contiguous virtual address.
Yes, you still have to account for that in your scatter gather map. But PCI was superseded by PCI Express. And from day one, the PCI Express specification stated that you must support 64-bit IO bus addresses. So hooray, finally we can count on that IO map registers are no longer needed and we can do direct map DMA operations. So the hardware designer says, okay, now we can get rid of this junk piece of hardware called the IO MMU and get rid of it. And in fact, on the last generation IA64 Itanium systems, they did get rid of the IO MMU. And they try to do that on x86 systems as well too. But luckily somebody finally stood up and said, wait, just a minute. We've just found a new use for the IO MMU. And it's now known with the name of the AMD BI feature or the Intel BTD feature. So on virtual machines, the IO MMU is used to translate an IO bus address directly to a guest virtual memory address space. So here's a block diagram of the MMU and the IO MMU. In a bare metal system, we know the CPU uses the MMU to translate virtual addresses to physical addresses. And on the device side, the IO MMU is used to translate a possibly limited IO bus address into a much larger physical main memory address space. In the virtual world, the CPU again uses the MMU to translate virtual addresses to physical addresses, but we also have a virtual MMU in there that is used to translate a guest physical address into a host physical address. So one more level there. And on the device side, the IO MMU now is used to translate an IO bus address directly into guest memory space without needing the buffer copies. So let's look at how OpenVMS works with PCI pass-through. So in this mode, the hypervisor does not load a device driver for the fiber channel host bus adapter. However, at power on, the hypervisor does set up the IO MMU unit with the guest to IO bus translation. The UEFI firmware also sets up the PCI configuration space to describe the host bus adapter, and it sets up guest IO space so we can access IO registers on the card. And when OpenVMS boots, it probes the PCI configuration space, and if it finds a supported fiber channel host bus adapter that it knows about, it will load PGQ driver as the port and DK driver as the class driver. PGQ driver runs exactly like it's running on bare metal. In fact, PGQ driver can't even tell the difference between running on metal and PCI pass-through. So in fact, no changes were made to VMS to get this to work. But that's a little bit of a lie, because the first time I tried this, things did not go so well. Shut down my system, installed a brand new PCI Express fiber channel card in the system, buttoned it back up, powered it back on, booted VMware, and went into my system configuration, added my fiber channel card to my VM configuration now. I booted my VM expecting some terrific magic to happen, and in fact, nothing happened. I logged in, there's no fiber channel port, there's certainly no DGA devices. So what happened here? It's like we didn't even see the adapter at all. Like, this is odd. So let's go into SDA and do a clue config and look at the adapters that we've probed during booting of VMS. And then that list, I'm going down the list and I say, oh, we found an adapter with the vendor ID of 1077. Oops, that's QLogic. We're onto something here. And I look over and the vendor ID is 2261. Oops, that's the the particular Q logic adapter that we know about and love. So why did we load PGQ driver for that adapter? Well, the next column told me why. The next column told me that that adapter was found on a PCI bus, not a PCI Express bus. And I'm like, wait a minute, the card I put it, I know it's a PCI Express card. In fact, in this system, you can't even install a standard PCI card on this bus. They've made notches in the cards to prevent that from happening. So how did that happen? And I thought a few minutes on this and I thought, okay, I think I know what's going on here. Something's funny. So the problem here is that most hypervisors emulate hardware models that predate the PCI Express bus. However, all brand new systems, they only have PCI Express buses on them. But the good thing here is the major change between PCI and PCI Express is in the very low level of how data is transferred on the bus. In PCI, it uses a parallel bus, whereas PCI Express uses a serial bus. However, the upper level software interfaces remain basically the same. So what the hypervisor does, it just simply lies and says this physical PCIe card we'll just pretend it's on a PCI bus and we'll go on. The problem here is that VMS has an entry in its configuration database for the QLogic card on the PCIe bus, but not on the PCI bus.
Type base delete one letter.
Yep, exactly. Well, actually 2 letters. So I thought, oh, this is an easy problem to fix.
Oh, okay. 2 letters.
2 letters. I forgot the device name. Yeah, you have the device name and the adapter. So that's basically what I did. I just duplicated that entry for the PCIe bus, for the older PCI bus, booted back up, and expected the magic to happen. Well, it sort of happened. I saw PGQ driver getting loaded. So I got excited and let's do a show device DG. Nothing showed up. That's kind of odd. And then I said, okay, let's look at the fiber channel port stats. And I did a show device FGA 0. Status was offline. That's bad. That meant PGQ driver, somewhere in the thousands of lines of initialization code, found an error and said, I give up, I'm going to set myself offline. So this started a multi-week effort of stepping through all that code to figure out exactly where the problem occurred. And the reason it took so long is because the problem was so deep down in the code. In fact, the driver mostly was doing everything you would expect a driver to do. It was getting everything right. The first thing it would do, it's read its PCI base address register out of configuration space. It would take that address, map it to a virtual address. Okay, now the driver can touch the control and status registers on the card. And for the QLogic card, one of the major things it had to do is to look into the flash ROM on the card, pull out the flash ROM, find the card firmware in that flash ROM in memory, and then copy from system memory into the RAM that's on the card. It did all that perfectly, including doing checksums on all that data to make sure we had a valid read and writes and all that. That all worked perfectly. Once it did that, it then commanded the QLogic adapter to start executing that firmware. That all worked perfectly. And we know that worked perfectly because the next step was creating a chunk of shared memory, allocating some shared memory, informing the host bus adapter where that shared memory was located. We created a command and response queue there. Everything was worked perfectly. We're even now to the point we put our first command on the command request queue. And basically the first command you send out to the QLogic adapter is a friendly hello. And sure enough, we get an interrupt back And the response from that interrupt is a packet on the response queue. And it says, hey, I'm here, I'm doing fine, I'm ready to go. Like, great. At this point, we've gone through about 75% of the driver code to get to this point.
That's the plumbing to the fiber channel switch.
Yeah, we're getting to that.
Okay.
So everything is working good at this point. The next command is we command the host bus adapter to make a connection to the fiber channel switch.
Oh, that's.
And when it did that, the response came back was, sorry, Paul, I can't do that. I'm like, what? This has never failed before? Did we forget the please bit? Is there a PCI pass-through bit we have to set somewhere? And I don't know where to go from here. There's no data other than an error code in the response packet. Have no idea what's happening. So I thought, maybe somebody tripped over a cable in the lab. So let's go down to the lab and take a look, and we traced out all the cables. The cables are all fine. They're all nice. All the connectors are tight. Everything looks good. We even go to the fiber channel switch and ask if the switch can see the host bus adapter the opposite way. And the switch says, link up. Doing good. Yep, all the lights are flashing happily. Still don't understand what's going wrong at this point. So still a mystery here. And the only thing I can figure out what to do is build a driver and make sure I dump every single item in the command packet and every single item in the response packet. And maybe there's a bit I've overlooked somewhere. About to do that, just when my colleague Rob Brooks comes to me and says, oh, by the way, I have some new QLogic firmware to install on your system. When would be a good time to install it? I said, great, now is a wonderful time to do that. Because I don't know where to go from here. So after a couple hours, he installed the new QLogic firmware, load up my latest version of the driver, and I step all the way down to the point where it's going to do the request to connect to the switch. And I step over that, the response comes back, connected. And I'm like, that shouldn't have happened. It's supposed to fail at this point. What's it doing here? Something has changed. I don't understand this. It seemed to work this time, but we'll go for broke and we'll just let the driver continue on now. And when I did that, I saw all these debug messages that I've never seen before, scrolling up several pages of information, scrolling and scrolling and scrolling. I finally get down to log in. Okay, the first thing I want to do is do a show status on FGA 0. Bingo, it's now online. Okay, now the final thing is let's do a show device DGA. Did that, and I see 3 DGA devices that I had pre-allocated on the SAN. Those are all there. Okay, let's try to knit one. Bingo, and knit works just great. Let's try to mount it. It mounts, and then I can copy files back and forth. Everything is working good. So I'm thinking about, so what did I do to get this to work now? I didn't change any logic in the driver, just enabled a bunch of debug messages. And I thought, well, sometimes having debug messages can change the timing. Let's go back and delete all those private versions of PGQ driver off and go back to the very stock original driver that I started with. Deleted all those off, rebooted, system comes up, FGA 0's online, my disks are online, everything's just perfect at that point. So it seems to be an issue with the firmware that I encountered there.
So now it was the documentation. It didn't have a minimum firmware level on it.
Well, that's what that was. I was exploring that. So after all that, we did find that PGQ driver works exactly like it's running on bare metal. In fact, Dave forever I exported PGQ driver on a bare metal Gen 10 system, and then we made no changes to get PCI pass-through to work. Now, when you have a fiber channel adapter out there, you have to go back to your alpha and titanium days, and remember, there are some restrictions with that now. You have to first only use only a supported fiber channel adapter that's supported by VMS. You have to have the particular fiber channel adapter that we have a driver for. You must use a fiber channel switch, and a supported fiber channel storage server. Fiber channel arbitrated loop mode has never been supported by OpenVMS and probably never will. You must go to your SAN administrator now and have them allocate you storage on that array that you're connected to. The SAN administrator must set up the user-defined ID, which is used as the OpenVMS unit number. And then when you do all that, you'll see device names such as FGA0, FGB0 for the port, and LUNs would be $1, $DGA, and your unit number.
I think you only see those if you also create a LUN 0.
No.
No.
Not anymore.
No, you'll, as long as OS unit ID is on the presentation from the storage array, you'll get a DGA number. 10 is for something else, and
Management, I think.
it's not even management. There was something way back when in VMS that wanted to connect to a LUN 0. I think it was GG driver.
GG driver to do the media robot or something. No.
But as long, the most common reason you don't see a DGA number is when storage SAN administrator did the presentation, he did not set OS unit ID.
Yes.
And there is an IO gen flag you can set where sysman will spit out saying, I found an FGA device, but it has no OS unit ID now.
But the important thing is these DGA devices now are formatted with the OpenVMS file system.
Oh, I have a question.
Sure.
So with the setting up the card, so in the Itanium, right? Many times we would need to go in and you're not doing any set. We go to the shell and connect to the card.
That's,
Is that it?
yeah, I'll get to that.
There's also a thing I've seen once or twice. Right.
The second most common reason for not seeing a DGA is that the zoning for the fiber channel storage array and the fiber channel host bus adapter is not right.
Along a similar line, I've had episodes where people had, because of the SAN being a sort of ubiquitous thing, where two people tried grabbing the same UDN.
Well, that's
The
been
different
the same-
devices, NatRecs have them.
Yeah.
That's
Be careful
been
of
the
zoning.
same design guide from day one. Across
Yeah.
the entire SAN, OS unit ID must be unique. It's a little bit of a lie. It's actually across the entire SAN per group of hosts OS unit ID.
Yeah.
Yeah, per SAN subnet, they must be unique.
Right. And the third most common reason for not seeing a DGA device on fiber channel array is the fiber channel port WWN has not been added to the host definition of the array.
Yes.
Okay, so I've mentioned locked memory a couple times. What is locked memory? Well, anytime you do a DMA operation within the operating system, right before the DMA occurs, the operating system locks the pages where that DMA is going to occur and locks them into memory, because the DMA then can happen at any time, and it doesn't know exactly when that's going to happen. But when the DMA is complete, it unlocks those pages. If it did not do that, those pages might be paged out or moved around somewhere else, and then you get a corruption in memory, or else you get corruption written to your disk, and you would not want that. But in the hypervisor, at least in the operating system world, we know exactly where the DMA is going to occur. However, the hypervisor does not know where in that virtual machine where that DMA is going to occur. So what it does there, the hypervisor simply locks the entire hypervisor into memory at that point.
The whole guess.
Yes.
Wow.
And this is then going to require a resource requirement on your hypervisor, and that may limit some of your system capability, your system capacity. So let's look at the fiber channels that will be supported in the V9.2-3 release. We're starting small with just the HPE Gen 10 systems and the SN1100Q QLogic fiber channel 16 gigabit card with just VMware ESXi at this point. Only data disk for support. Booting a fiber channel disk is not supported, and I'll talk about that in a minute. Some of the challenges we're having with booting. In the future, we'd like to get, support the 1600Q 32 gigabit fiber channel HBA. The good news here is that card is almost identical to the 16 gigabit card, except for this faster speed. So we don't have to make any changes, or very minimal changes to PGQ drivers to support that card. With the 1610, we kind of ran out of luck there because QLogic invented something called secure firmware load mechanism. And that requires changes in PGQ driver to follow along with that new way to load firmware on the card. Make sure that you're only loading QLogic firmware on the card. And we'd also like to go back to Linux KVM and document all the ways to set up PCI pass-through there. Some of the complexities I already know about. For example, in Linux KVM, the first thing you need to do is set up boot command line options that are different for PCI pass-through. So the instructions I had gave me the instruction to do that with grub, but on my system was running grub 2. So that's yet a different way to change your boot command parameters. The second thing is that Linux does not provide a GUI interface to easily add a fiber channel pass-through card. So you get into writing your own XML code to describe that fiber channel adapter and adding that to your configuration file. So we'll have to document all that. And I'm sure there could be a few other steps beyond that.
File, you have the XML.
Yes, unfortunately.
Never mind, because I'm gonna ask you something which is not on that slide.
Okay. So all this work is in progress. We're just going to get it done in time for the V 9.2-3 release, but we're going to try to get it to you as soon as we can. So I mentioned booting is not supported, and there's a couple of issues here. The first one is in our control, is that booting of a fiber channel cluster common system disk requires the testing and qualifications of all that code. Now we know that code worked back on Alpha and Titanium, but we need to look and understand what we've done on x86 system that could have possible impacts here. And a couple areas we're looking into are things like the memory disk, possibly maybe the dump kernel may have some interactions there. We need to go back and look at all that code to make sure there's no problems there and complete the qualifications to do that. That's at least a problem that's in our control. A much more difficult problem that I discovered is with the firmware that VMware ESXi provides in the virtual environment. When you have a bare metal system, the first thing that happens when you power on the system is the UEFI firmware goes out and pulls every card on the PCI Express bus, and if they contain a boot ROM in them, it loads the driver, the UEFI driver from the boot ROM and runs it. And at that point, the driver then materializes FS0 devices for booting. However, in the virtual environment, the UEFI firmware provided by VMware does not seem to do that, or at least I could not find some undocumented options to try to turn that on. I tried a number of undocumented options and none of them worked. So I did find a couple of hacks, and I'm only calling them hacks at this point because they each have some very unpleasant side effects. The first hack I found is that you can go to the QLogic website and download the support file for your particular fiber channel host bus adapter. And if you're lucky, you'll get a zip file and you'll find the UEFI driver in that zip file. You then have to take the file that's in that zip file, copy it to a UEFI partition on a local disk on your system. And then when you power up your virtual machine, you have to go to the UEFI command prompt and manually load that driver file from the local system disk. And when you do that, you'll type the load command. I think it's the load command. And it usually takes, depending on your adapters, it can take maybe, say, 45 seconds. And you've probably known this from like Titanium systems with fiber channels. They take quite a while, but note when you load that driver, and if you have a dual port adapter, it can take a minute and a half. And you probably see similar issues when you powered on titanium systems with fiber channel adapters. They can take quite a while to power up. When you do that, it materializes your lens available for booting. And then you can go from there. But the drawback there is that you have to have at least one local disk to hold the driver file. So that means you can't have fiber channel only configurations. The second hack that I've been told about, but I've actually not tried, is apparently with VMware, there is a zip file somewhere containing all the firmware that's loaded in a virtual machine environment. And apparently you can unzip this file somewhere, add the QLogic driver to that directory structure, update a manifest file to indicate that the file is present, zip that back up. Okay, now you have a custom firmware load for your virtual machine. And then you could possibly have a fiber channel only machine with that custom firmware. But that means you're modifying files on your VMware systems. And I don't know what happens when you try to do an update to the next version of VMware, whether that file would be deleted perhaps or whatever. I don't know what happens there.
Probably have to redo the update again, just like we did in the old days.
Possibly. Sure.
Have you looked at the Q-Converge console that they provide for the QLogic cards in VMware?
No.
Okay, that lets you do that. And there's also an ESX CLI plugin from Marvel that does exactly what you're talking about.
Okay, well, maybe that's another option we need to look
And
at.
whether it will work with any of this, I have no clue.
Yeah. That's something we'll take a look at. That some of those could be still for only mode 1 operations.
Yeah.
That may allow you to take an older version of EXXI without the necessary driver and add the hypervisor driver for that version of
I
it.
know it lets you get into all the BIOS settings without having to reboot ESX to get into it.
And in fact, that's what I had to do in this case you need to run setup to set up your adapter for booting. And the only way I could figure it out is to shut down the whole VMware system and use the setup utilities at the bare metal prompt. And once I did that, rebooted VMware, and when I got to my VM, all those things were set up and ready to go.
Right before I came up, I was looking at the PCI pass-through option for KVM for another reason. So I'm almost at the point where I'm going to start playing with the XML and the KVM configuration file.
And just like you also have to be aware, if you do just that, you can get into a situation where two people own the fiber channel adapter. And then you can bug check your entire VMware system, because then you got two people. You got to watch the boot command line options there.
Well, easy. We have one guest on the machine anyway.
So now let's rewind a bit and go all the way back and look at ESXi in mode 1 configuration, where the hypervisor owns the fiber channel host bus adapter. Basically, everything is defaults to this, so it should already be set up. So you'll see your in your list of PCI adapters here, you'll see that the pass-through column here, the adapter is disabled. So that means we're in mode 1, where the hypervisor owns the fiber channel host bus adapter. And if you poke around a little bit further, you can see there's the fiber channel adapter and the driver that's running there. That's your VMware driver that is owned by that's the VMware driver. That's certainly not a VMS driver at this point.
Oh, pass-through disabled.
Pass-through is disabled,
Okay.
and that's the way it normally will come up first. So that's the hypervisor driver. And if you go into the data store, you'll see the file system type is VMFS6 on that fiber channel data store. That's certainly not a file system that VMS knows anything about.
Get that to say ODS2 or ODS5. I'll take it at lunch.
Thanks.
And then when you boot your VM in this mode, you'll see devices like DKH0. And this one was attached to a virtual SATA device. All we know, it's a virtual SATA device. As long as it plays by the SATA rules, we don't care where the data comes from. It could come from the moon at this point, as long as it plays by the SATA rules, we're fine with it.
Once you're going through the ESX file system, the file is a file is a file is a file is a file. It doesn't matter what it's on.
Yeah.
But you cannot present a raw volume and have it picked up and be able to use it.
I've never tried that.
I remember a Camille slide somewhere out there saying,
You
no,
can do
no,
that. But it doesn't work in a cluster.
yeah,
Well, yeah, it's a,
Yeah.
you have, once you accept the fact that it's a VMware file system, all the limitations of the VMware file system are imported by reference. It's a file, it's a file, it's a file,
Yeah.
file. As far as VMware is concerned, and you don't see anything but that.
So now let's look at an example of how you transition from mode 1 to a mode 2 configuration. So back to the original, you see your fiber channel adapter here is listed. And now we have pass-through is now active in this configuration. And the way you go about changing from disabled to active is you use this toggle pass-through button. But before you press that button, there's two things you need to be wary about. First, you need to make sure that there are no other VMs on the system that's depending on the fiber channel adapter for their storage, because they will lose connection to their storage when you transition to pass-through. Also, when you hit the button, you will have to reboot your entire VMware system. And that allows VMware to back off and not touch, release the fiber channel host bus adapter. So once you boot back up VMM, your virtual machine, you boot up VMware, you go to your virtual machine and you go to add other devices. And you go down to add PCI device. And then you can add your two fiber channel adapters here. Now this is a dual port card. So you must add both ports to your virtual machine. Now both ports appear as two separate PCI devices. So you might think you could split them, but no, both of those PCI devices are behind a common PCI to PCI bridge on the card. So you must add both devices to that virtual machine. If you don't, I think we'll get a machine check if you don't add both.
If you're lucky, you'll get a machine check.
And then hopefully you'll be able to, you go to power on at this point, but whoops, you're going to get another problem that's going to show up. Remember when I was talking about locked memory, you won't be able to power on your virtual machine until you check this box to enable locked memory. And that's in your memory configuration. You probably never noticed it before, but now you'll need to make sure that's checked to power on your PCI pass-through system. And then if all goes well, you'll see a device like FGA0. You'll need to note your fiber channel port names here to give to your SAN administrator, so he can then allocate you storage against those ports. And you'll notice at the bottom here, the adapter max speed is 16 gigabits a second because it was a 16 gigabit card. But if you look over here, the current speed is set at 8. And the reason it's set at 8 is because it's connected to an older 8 gigabit fiber channel switch. So the QLogic card had to downgrade its speed to the speed of the switch. And that's probably where the firmware problem came about, that the older version of the firmware was not correctly downgrading to the lower speed.
the port number is not like an NPIV number, it's the actual port number on the card itself, right?
It's the little tag on the back of the card that has the barcode on it.
Yeah.
It's not, it has to be, it's not a question of allocating storage, it's a question of
It's easier to
additional
read
storage.
than that. It is.
You can read it from there. You can, in the ILO, I think it shows up there.
Yeah.
But
And
you
it's
can't
on the tag as well,
virtualize those as well. You can do NPIV, but this is not, this pass through is reading the actual ROM and getting the port number from the card itself.
It's not NPIV. Paul, just a phraseology note, it's not allocating, it's probably better not allocating storage, but provisioning storage. If you
Okay,
have a real-
provisioning,
If you
okay.
have a real node, titanium or alpha, accessing that volume, you need permission.
Paul,
And Paul,
was this a dual port fiber channel card you were experimenting?
yes,
Then,
so you would see there would be an FGB 0 configured there as well too.
oh,
I just
you're
did-
saying you get two WWNs for
Yes.
the
Yeah.
A and the B device?
Yes.
Yes.
So which one is this pulling when it says, port, port WWN there, fiber channel port name, which one is it pulling there?
That's only on the first port. You'd have to do a show device FGB 0 to find the other port.
Which will be D2,
So those will
A2,
be numbers
and
ending in 2 and 3.
D3.
So you could split that part.
No,
Not inside of
Then
VMware.
I'm missing something, and I'll talk to you about it later.
You cannot take one card and split it into two separate island usernames. There, you
Okay.
cannot take those two ports.
The domain is on the physical card itself, not on the ports.
Oh, I got it.
Because of the common PCI to PCI bridge that's on the
I
card.
got it.
And that's, you'll see, if you're lucky, you'll get a
that might be exciting.
DGA device that's, on this one, it was on a HP MSA 2040 SAN. And at that point, you're ready to emit and mount it and use it whenever you like. So the futures for Fibre Channel, HP already has on the price list a SN 1700Q card, which is the 64 gigabit generation of QLogic Fibre Channel adapter. And that's something we'll possibly consider in the future for OpenVMS, in the distant future. But to go along with that card, you're going to need a 64 gigabit Fibre Channel switch and a 64 gigabit storage controller. And the last time I looked, I didn't see any of those available. So those are still in the process of being rolled out. Maybe that's something you put on your Christmas list either this year or next year. And on paper now, there's the 128 gigabit Fibre Channel specifications are now available. And I'm sure the Fibre Channel vendors are hard at work implementing prototypes for that generation. And throughout this presentation, I've exclusively referred to QLogic here. And I do not mean to say that QLogic is any better or any worse than its competitor Emulex. In fact, full disclosure here, I worked for Emulex for about a year on Fibre Channel firmware. The problem here is that the 4 gig, the Emulex driver kind of got orphaned at some point in VMS, and it still needs to be ported to x86. Once you do that, it was left off at the 4 gigabit generation. It then has to be brought up to the 32 gigabit generation, and all that work is just not planned at this time. And it's on the very bottom of the list at this point. So,
It's not on the list.
yeah.
It's not on the list.
Over the
That's the list, thrown out of the list.
beyond the horizon.
I have a soft spot in my heart for Emulex because I worked there. I'd like to see it at some point, but I absolutely realize that it's going to be a long time before we get around to it.
So how about the the fiber channel on Alpha?
Well, the Hyper-V, which you're not, I know on the long duration futures, if at all, Hyper-V implements fiber channel switches, I believe.
Yeah, that's
Is there any-
another long pole that
Is there anything in ESX that allows you to do a fiber channel switch access as opposed to a dedicated port?
I don't know of anything at this point.
Because you have the obvious problem if you're going to take a 64 or more core x86 and split it up into a bunch of VMs. You obviously cannot have that many HVAs plugged into the back of the server.
This is NPIV.
Yeah.
So you could do that, but that's a whole different animal.
So here's kind of a comparison of mode 1 and mode 2 configurations of your Fibre Channel host bus adapter. In mode 1, the hypervisor controls the Fibre Channel host bus adapter. In mode 2, OpenVMS controls the Fibre Channel host bus adapters. In mode 1, the LUNs are formatted in the hypervisor file system. In mode 2, the LUNs are formatted in the OpenVMS file system. In mode 1, you get virtual interfaces to disk files. In mode 2, VMS gets direct access to the LUN. In mode 1, you get DK device names, whereas in mode 2, you get DGA device names. In mode 1, DK devices can be shared via MSCP, and in mode 2, DGA disk can be shared by fiber channel clusters. In mode 1, you get bounce buffers in the hypervisor, whereas in mode 2 takes advantage of the IOMMU and locked memory to DMA direct data directly from the card directly into OpenVMS guest memory. With mode 1, it's easy to migrate a virtual machine with vMotion, but vMotion is not possible with PCI pass-through. In mode 1, Fibre Channel HBA can be shared by many virtual machines, but mode 2 requires a dedicated Fibre Channel host bus adapter to each VMS virtual machine, and of course, locked memory.
Just a quick question, all on the comparison. So is it basically choosing one versus the other? Is it basically just a performance thing, or like, why would a customer, look at one versus the other?
Well, you can do both. I mean, going back to my presentation, I actually have on my hypervisor, I've got Fibre Channel pass-through enabled, but I also have an HBA dedicated to the hypervisor. So you can actually have both.
So this is the card numbers.
Well, and depending on how many adapters you have in your hypervisor.
And depending on what your requirements for your virtual machine is, if you need a high performance access to storage, Fibre Channel pass-through is the way to go. Maybe you don't need any particular storage requirements, and mode 1 configuration that maybe works just fine for you.
If you want to run a cluster, you probably want to take more too, so.
Yes.
You don't lose access to the disk on the machine.
They wouldn't be able to do vMotion. You wouldn't be able to do the adapter to conscious and all the other.
You can have everything, but then, I mean, if you've got a VMS cluster, why would you want to do it in motion?
Probably better.
No, I agree. Work on the hardware.
So,
So
so in summary, Fibre Channel makes the transition from bare metal to the virtual machine environment. And there are 2 methods to use Fibre Channel in the hypervisor environment. In mode 1, the hypervisor controls the Fibre Channel host bus adapter. In mode 2, OpenVMS controls the host bus adapter through PCI pass-through. And just like we've talked here, both methods have their own strengths and weaknesses. B 9.2-3 expands the use of Fibre Channel on virtual machines via PCI pass-through. However, as we've discovered here, there are some limitations to the use of PCI pass-through. You want to use the method of Fibre Channel based upon your particular need of your particular VM. And Fibre Channel technology, along with OpenVMS, continues to evolve into the future. So, any questions?
into a storage presentation. Go ahead.
You have a question?
I had a quick one if I could, so I can run.
Okay.
Has there been any thought to supporting the endpoint virtualization? So I'd say virtual HBA VMware that you can then share with multiple guests.
We've looked at that a little bit. I'm not sure where the support is in the driver at this point. That may be another project to take a look at.
So getting back to my other question, initially, right? So the in PCI pass-through, the cards, they must come already set with the scan level set, so it goes up opposed to fabric. And because, in the past in integrity, we would have to go in and, sometimes we'd toggle that on and off, because if the customer didn't have a zoned, a really good job at zoning, sometimes we would be scanning a couple of the devices here at VMS food, right? So, being able to do the scan first and then shut that feature off, and then everything's going to be RAM, so we don't need it after that. So these cards are coming through basically set to scan and
Yeah, I don't think you can depend on any particular setting in these cards. I think you're just gonna have to look to see.
So to get to that card for the setting is,
Right now, the only way I could figure out how to do that is shut down the whole virtual machine. Shut down VMware totally and use the bare metal to get to that
the
setting.
bare metal to get to that.
Now, maybe there's maybe we'll find a better way to do that, but right now, that's the only way.
That was my only thing, trying to think of how you would get to the settings on the card if we needed to. So,
Yeah,
okay,
you will have the same problem with all the problems that you've had before. You're gonna have them here as well.
All right. If we can figure out how to make the UEFI firmware in the virtual machine load the firmware from the HBA,
oh,
then
yeah,
we should be able to do that from the
Right.
firmware prompt in the virtual machine. We haven't gotten to that.
yeah, no. But it's something to think about because it could, when you were talking 45 seconds or so, right? Per poll on those cards, right?
Yeah,
But then if those cards gotta go and pull fabric that's not zoned properly, there's another amount of time that's going to, sit there and spin while you're waiting for it to pull all the devices. Okay, thank you.
Well, that's the reason that usually that parameter is turned off. It's been my experience, the only time I have to turn that back on is if I have forgotten to run, against, the update the boot options menu on Integrity to make this escape. It's the third day of the week. Anyway,
So I don't.
you change where you want to boot from, but before you shut down the machine, you've got to add the boot entry. So now you're sitting at the EFI. The EFI doesn't see the FS device that you want. You have to go out there and turn on the scan, so it scans everything. Then you boot BMS and you do what you should have done before you shut it down. And then you can go out and turn that bar off again.
at least with x86, we have the boot manager that can help you associate an FS device
Yeah.
to a particular VMS device.
Right.
So that's helpful.
Yeah.
That's the end of that, so it is, I'm trying to, in my mind, meld the two together, yeah.
I think I've hit your problem.
Yeah.
But my question actually was, even with PCI fiber channel pass-through, you still don't eliminate the problems on x86 of a common cluster system.
Right, we haven't quite.
Right, and as I remember, one is the boot kernel,
I mean, it's not.
and I forget what the
Yeah,
other.
the dump kernel.
Dump kernel, and I forget what the other two reasons were.
It's the kernel and it's the memory disk.
Oh, yeah, I remember that when Richard was originally doing that back when he went from the LVM device having a fixed number of one.
Oh, thank you.
Generating.
Thank you guys very, very much.
I remember that.
These two sessions back to back are absolutely wonderful.
That's what we're trying to partner up here.
So if you were getting, starting from scratch and looking at the next couple of years, like, is there any difference if you had a 1011 built really, would that cause a difference with the existing stuff that you guys got, or you can?
Well, the 16-bit, the 16 gig card doesn't work on a Gen 11, for example.
Yeah, you'll have to wait for the updates to 923, which we're planning for June of next year. That will add support for the 32 gig cards. And that SM1610Q card, that's the card that's supported on the Gen 11 system.
10 basically is.
And I think part of that is the newer systems have a newer generation of PCI Express on. So they want you to use the cards that match those. I think that's one of the reasons.
Pay attention, what you're ordering, what's the options you're ordering to make sure that you have the right variants, when.
With the version one and vMode, download vMode subsession DRX. To make it.
Camille, you've used vMotion, haven't you?
That works.
So DRX probably automatically DRX sets automatic.
If you have everything set up correctly, it will work just like any other version.
Behind Claire,
Can you talk, what is the UCP of the KPS?
basically just a matter of documenting all the steps that you need to do that. It's just a little bit more involved than a couple GUI settings that you can do with ESXi. That makes it very easy, but there's a lot of manual steps with
You
KPI.
and I need to spend about 5 minutes talking about
Well, it's documentation and it's qualifications.
Yes,
Yeah.
qualifications as well.
Suite of CTM tests, and doing it on both AMD and Intel because the IONU options to the boost are different between the two. It's a lot of mechanics.
So you need a dedicated ESXi. And you can't shoot from the pipe
Right,
coming.
that's coming.
Well, we hope.
Yeah.
No extra charge for that.
Thank you.
Yeah, but the fiber channel pass-through speed is great.
Yeah.
Thank you. Yes.
There's.
Yeah, there's that ice cream.
There's the, yeah.
And if you didn't get a chocolate,
Fiber transport back there.
Oh, yeah.
And they're ready to do that.
But for the reason. So this was. No, but it's why it's
I'm giving away chocolate. Entice people into session.
Amazing. You did the session? Why this session?
Well, I was right before. So
We're
there's-
adding you, who else are we adding?
EGOR, gives you C.
Now,